of the Trustworthy AI Institute for the NIST NSF. I'm going to speak English now. I'll try one more time. Okay, this is Hal Domay, who's a professor at University of Maryland, and he's also the PI of the NIST NSF Trustworthy AI Institute for Law and Society. And he is the moderator of our second panel, for which I have the questions here, if you need them. Okay, so let's begin.
All right, we are missing a panelist.
Yeah.
There we go. Excellent. The dramatic entrance.
Of those Europeans, yes, exactly.
So I'm sure you've all been thanked for being here many times. You are thanked again for being here. You know, as with the other panels, we want to make sure that there's time for audience questions as well. So, you know, I have prepared questions, but we welcome questions from anyone. So this panel in particular, as you can see actually, I guess it's not on the slide. Yes, it is. It's just hard to read, is on sort of this continuum between open and closed language models and sort of the implications of that for data governance. I think, you know, the backdrop against which this panel is happening is there's been a lot of folks out there saying, you know, my model's open, no, my model's open, no, your model's closed. And like, no one can seem to really agree on exactly what this means. And hopefully we won't agree either, because that'll make it more interesting. So I think what I'd like to do for starting is just to start off with this very broad question of like, what does open and closed language models in particular mean to you? And we'll just go one panelist at a time. But before you answer the question, please take a minute or so to introduce yourself. So we'll start with Alek, and then Aviya, and then Sayash.
Hello, everyone. My name is Alek Tarkowski. I come from Poland. I'm a co-founder and co-director of a Dutch think tank called Open Future. We're a think tank for the digital commons, and we've been involved in conversations around data and AI in recent years, also coming from a perspective that tries to look both at the kind of data governance issues we've been discussing, but also copyright issues, which I know are a bit out of scope of the conversation today, but nevertheless, I'm mentioning it because I think this unified sort of holistic perspective is really important, and probably I expect copyright to emerge anyway in this session at some point. So again, as I said, I'm bringing here a European perspective, which I know is slightly different from the US one. The debate is a bit different, but I really believe in transatlantic dialogue, as I like to call it a bit formally, in sharing experiences. So obviously, Europe upped the ante a bit in thinking about definition of open source, because hinging on the definition regulation will depend. That was quite a roller coaster. If any of you follow the AI Act hashtag in social networks of all sorts, you know that they organized a marathon last night for 22 hours, apparently, or more. It seems, and then, well, so I think what I find interesting is that it sort of, I think, will change the conversation if Europe really pays attention to what open source means. And as far as I understand, that will happen, though who knows. So I have a regulatory perspective. I imagine Aviya, for instance, might have a more looking at it from a technical side. I think it's crucial to develop this standard. Starting with this perspective, I think open source has been extremely valuable, and this is probably clear to all the AI developers who basically work with open source technologies, but more broadly. And I think it has been acknowledged in a range of also public policies, and I think we'll come back to that. Not just open source, but other sort of flavors or aspects of open. I think open science and open access is a really important perspective here. And the US had some recently big successes with things like the so-called Nelson Plan that you maybe heard about. I think we should also keep that. I know we're focusing on open source, but the context is broader because it explains why openness is important. But so that's the starting point. But the interesting and tricky thing is that almost everyone agrees that sort of a vanilla canonical approach to open source will not work because there is something different with the technologies, and there is something different with the calculation of sort of, you can call it risks and benefits, you can call it rights and wrongs, but and the tricky thing that happens there is that then things get complicated. You get proposals that are sort of coming from the development community, like the Rails licensing model, supported, for instance, by Hugging Face, who are here in the room, which asks very interesting questions. How maybe you need to limit open source in name of broadly understood responsibility, but then you have moves made by big commercial actors which also limit open source in ways which you can probably still frame as some of them as responsible use, but there are also quite a range of limitations in models that were discussed today and which are prominent ones that can be seen as anti-competitive. For example, both Falcon license and the new Llama 2 license have measures that are broadly speaking anti-competitive, and I think are a lot more challenging, for instance, from the perspective of policies. And maybe I'll stop here. Last thing, sorry, transparency. It was mentioned today that there seems to be common agreement that transparency is a required factor here. Traditional open source development in practice, I think, is based on the principle of transparency. But I think there's also a strong commitment that this should be self-regulated. So I think the big debate is that if that's enough. And as an ambassador of the European perspective, I will say that it seems that there's a growing consensus, at least in Europe, that we can regulate this requirement for good.
Hello, my name is Aviya Skowron. I'm at Eleuther AI, where I'm the head of policy and ethics. Eleuther AI is leading LLM research nonprofit that releases both models and the technology needed to run them or evaluate them open source. So I sort of represent the open source developer perspective. The debate, we think, has gotten muddy around what open source means and can mean. So in traditional software, open source is a way of sharing code that permits anyone to run it in any way they see fit, to study the program, to modify it, and to redistribute both the underlying code and whatever modification you made. There are obviously ideological reasons why people like it, but there are also very practical reasons why people like it. Notably, it extremely simplifies software development. It means that your team does not need to have a legal department before it's ready to have a legal department. And we think that it's important that whatever we call open source in the AI space has similar characteristics. So for example, we're working with the Open Source Initiative to sort of put out a definition and find a common standard that's satisfactory to all the stakeholders. And we definitely think that the model weights themselves and the code needed to run them needs to be shared open, under an approved open source license. And where the differences are actually in the data. So as you know, machine learning models are built on the data that we're discussing all day today. The debate within the open source community is what level of access we need to the underlying data that the model is trained on in order to call a model open source. And it's probably where we're probably going to be landing is at least we need a description that is satisfactory enough to reproduce the entire data set. It is clear. So there's some precedent for this happening within the machine learning field. And we're hoping that that's the minimum that we're going to reach. Because otherwise you're not truly able to study the model to a level that is equivalent to what you would find in traditional open source. So that's sort of our perspective. And I do think that it's important that we maintain this clarity because frankly, it just has gotten very confusing for everyone. And there are companies that started using models that, like Meta will call Llama open source. It isn't, the license isn't. It has certain restrictions. And there are companies that have made the mistake of actually deploying it in a particular way. And only later found out that, because someone told them that it's not actually open source, in the sense of permitting all use cases. I have many more points because I'm representing an open source developer, but I'm gonna pass it to Sayash.
Thank you, Aviya, and thank you, Alex. So I think both of the answers so far have been great. Before I jump into my answer, I'm Sayash Kapoor. I am a researcher and PhD candidate at Princeton University's Center for IT Policy. And my work broadly is concerned with AI and how we can regulate AI better, but also with how we can evaluate it and questions around how we can even sort of certify an AI tool is fit for use in various contexts. I think this is the perfect start to this, this panel is like, what do we mean by open? And I want to sort of quickly zoom out a little bit and talk about like, why are we even having this debate in the first place? So one of the main concerns around AI in the last few months, and maybe perhaps in smaller corners of AI community for the last few years, has been the risk of misuse. So a lot of people who are concerned about these risks say that as soon as you release a model's weights openly, that is to say, as soon as you make it so that anyone can run a model on the computational resources of their choosing, you also bring with it like a lot of risks. Some people have said that you can use models like GPT-4 and Llama to create like pandemics, perhaps, or perhaps future models would be able to bioengineer new kinds of pathogens and create pandemics. There have already been many concerns around the use of Llama, for instance, which is Meta's open model, that is, they release their weights openly, for creating disinformation. In fact, Senators Blumenthal and Hawley even sent a very strongly worded letter to Mark Zuckerberg a few weeks after the Llama model was released. So I think the debate is happening in this context where a lot of people are concerned about all of these massive risks of open foundation models or of open AI, where open here I'm using is, a model's weights are released openly. On the other hand, we also have like the developer community and the researcher community, which is concerned about being able to build on these models. As Aviya recently mentioned, I think it's really important to be able to access the underlying data, the code, and the weights themselves in order to be able to do a lot of this research. And so that's where the word open source comes in. Now, the distinction between open and open source is, like, I think a subtle one. Open source means you have access to the model's weights, the code, and in some cases, as Aviya mentioned, you might also require the data. Whereas for open foundation models, as I'm using it at least, I only mean the model's weights are available. So while people who are concerned about misuse are concerned with the former category, people who are concerned about being able to build on top of these models to promote innovation are concerned with the latter, very broadly speaking. And I think it's worth sort of teasing apart these distinctions because then it helps us understand what arguments we're responding to. So one thing I'll highlight very quickly before we jump into the next question is that when we're talking about any type of policy making that happens as a result of these models, I think it's important to be empirically grounded. So what I mean by that is we need to have evidence of how these models have been used and misused in the real world in order to form effective policies. And one of the key places where we are missing such empirical evidence is in concerns around, you might have heard them being called like existential risks, that is risks from these AI models that are so large that we should just not like build these models, as some people have argued, or others, most prominently those whose concerns are aligned with the industry, have argued that these models shouldn't be released openly and that they should remain inside the confines of the industry, perhaps only to a licensed few companies who can build these models. And I think this is one of the riskiest arguments that is being made today because it is not grounded in any empirical fact. People have organized like forecasting competitions trying to sort of forecast the probability that we'll die, when in fact such probability calibrations are not even possible using existing data because probability relies on the concept of having encountered similar events before. And if you're talking about human extinction, probability just is not the right framework to think about it. So in the absence of probability, we must go back to grounded empirical facts. And the fact is we have no evidence these models can produce any sort of like humanity-killing pathogen. We have no evidence, in fact, that any of these existential risks are real. And so therefore, we must shift the conversation from the former definition of open foundation models, that is foundation models that can cause misuse, to the latter definition of open source models, that is models that can be used to promote innovation and to promote scientific progress. So I'll stop at that and like hopefully we can dive into this more in the coming few minutes.
Yeah, thanks. So I think the next thing I wanted to ask about actually follows on this really nicely, which is really just thinking about what are the potential cases of both sort of positive use and potential misuse of And I like your distinction between open and open source. So I'm going to specifically say open source. So things where you have not just code and model weights, but at least something about the data. And we can, maybe discuss later what that might be. But, there's arguments in sort of favor of both, but I like this idea of sort of trying to empirically ground it. So the broad question is, what are the costs and benefits? But actually what I'd love to hear, if any of you have concrete examples, is like, what is an actual concrete example of a benefit that's come out, and what is actually a concrete example of a misuse that's come out? So maybe let's shift one over. So we'll start with Aviya and then go to Sayash.
So since we are a research organization, my examples of use will be focused on research specifically. And I wanted to highlight that there are entire research areas within the field of AI which are impossible without the full open source release of the models and open release of the data. That is, you have to have access to the data in order to answer the research question. And one example of such a field is memorization, which is of great interest to policymakers. Policymakers want to know, and as well as rights holders and artists and content creators want to know, what is the likelihood of reproducing the training data, and how often does it happen, and to what extent, how large is the chunk? All of these questions and everything that follows from them can all be investigated with full access to the open data. So I think, actually, Alex at the previous panel mentioned Nicholas Carolini and his studies on memorization. The reason that study uses the GPT-Neo model from Eleuther AI is because we released the training data set, and because Google lawyers came to him after his previous paper to redact it. This is public information. It's like buried in a Reuters article, but so you can verify this if you Google Nicholas Carolini. So again, vital research that's completely impossible without sort of the foundation that we've laid with our open work.
All right, so I'll quickly jump back to another of the risks that has been claimed about these models and sort of try to look at, again, the grounded empirical evidence. So we talked about biorisk like a little bit before. I think one other risk that has been sort of proclaimed as almost world-ending or catastrophic is the risk of cyber attacks. So the theory goes that once you have foundation models and language models that are good enough to code and to write code and to improve other people's code, they can also be used to find vulnerabilities in existing critical infrastructure. I think lots of people have made this claim, including at OpenAI, that foundation models and language models in particular can be used to find vulnerabilities, target critical infrastructure, and cause massive havoc and damage to the economy. So let's dive in. The key claim being made here is that AI can scale more or be faster at detecting such vulnerabilities compared to, I don't know, like just humans or a team of attackers and so on. And so therefore, it will greatly advantage the attackers. Now, this sounds plausible indeed. These models are really good at some parts of writing code. I've used them for creating websites and so on, and it's all good and like fine in that. The question is, how much of a capability boost do these models give to attackers versus to the defenders of the system, who can also use these tools, by the way, to identify security threats? And note also that these defenders have much better access to their critical security infrastructures in the first place. They can access the code, they can run these systems automatically, and so on. And we can actually look back to a previous technology where this was possible. So 20 years ago, or at least 20 years ago, we developed these tools called fuzzing tools. Fuzzing tools are used to automatically detect some kinds of bugs when it comes to critical infrastructure. They've been used to find like tens of thousands of bugs in all sorts of software infrastructure. And most importantly, if you think about it, these tools are in some sense superhuman as well, because they can find these bugs at a rate that's much faster than any human who can possibly go through this code. So what has the effect of fuzzing tools been on the state of security in the real world? Well, fuzzing tools have actually been responsible for improving our security capabilities by a lot. So they're constantly being funded by governments and cyber defense agencies and so on in order to protect this critical cyber infrastructure. And they've actually led to an increase in security as opposed to like these risks. And the same thing is happening with language models as well. So Google has this tool called Palm. They now offer this tool called SecPalm for Security Palm, I think, which is used to find vulnerabilities in critical code. Similarly, there are these like large-scale fuzzing platforms. So OSS Fuzz is a fuzzing tool that's used to find security vulnerabilities in open source infrastructure. They have now been sort of amplified by the use of language models within these fuzzing tools, again, to greatly improve the critical, improve our ability to protect critical infrastructure. So in all of these cases, I think the concern around like cyber infrastructures going down just because we have open models are somewhat misguided, simply because the empirical evidence does not bear this. And in particular, like having access to these open source models is particularly important for smaller organizations that are trying to defend their systems, because they can investigate how these models are made and they can run it on their own infrastructure to find these vulnerabilities. So once again, I think the story is somewhat the exact opposite of what we're being told by these larger companies that want to license these software or sort of make it so that only just a few small set of companies can release language models. In fact, these language models are necessary, I would argue, in order to improve our critical cyber infrastructure. So that's one example of a perpetrated risk of these models that is actually turns out to be like a huge benefit in practice.
So I'll try to tackle this from a slightly different perspective. I think this angle concerning security and research and innovation is very important. But I think there are important issues related to concentrations of power, because in the end, if you look from a systemic or a policy perspective, that's one of the things you want open source ecosystems to do, to distribute power. But then here I want to step back just a bit and talk a bit about risk. I think the conversation about open source will take place in the broader context of the conversation on AI risk. I don't think that's ideal. I think we should also have a conversation about innovation, about generative capacity of this technology. But the way this debate seems to be shaping, it will be about risks. So I think the challenge there is that the typologies of risks are incomplete. There's as far as I understand, I'm not an AI developer, so correct me if I'm wrong, but there is, I think, a pretty popular taxonomy of risk published by the DeepMind researchers. And it has I think it's pretty good, but it lacks, from my perspective, one thing: any mention of the issue of concentrations of power as a risk that we are facing as society. This happening especially after the last decade, and the issues we have with the domination of platforms is just myopic. And I think we need to fix that, because otherwise we'll continue having conversations whether open source contributes, to all sorts of other risks, which fair enough it might, such as disinformation and misinformation, but it's very hard then to discuss an important class of benefits. And just to illustrate what can this distribution of power mean, I'll give one example: Wikipedia. I don't know if you're here expecting to have a conversation about Wikipedia. I think it's extremely important. Wikipedia is thinking how to augment basically the work of its editors with AI tools. It's a relatively big organization, but still with a budget that's really small in terms of what we heard about how much it costs to train models. It also runs an extremely outsized, wonderful website that just sets a platform that's very different from all the other commercial ones. And they've implemented now a translation tool, which is basically based on, I think, 3 different existing open source language models. They do interesting stuff, by the way. These models are a lot better in dealing with rare languages, which Wikipedia really cares about, and more generally Wikimedia. I think it's a very interesting case, which if you look more closely, demonstrates economic benefits. But I would look at it even more broadly, and maybe that's one point I didn't make earlier. We need a sort of formal definition of open source, which is basically about licensing, but we need also like a full stack thinking. And here I really like the Bloom project, because in it, you see it's not just about how you license, it's also how you collaborate, how you build community standards around it. And you see the same thing with Wikipedia. It's not just about, oh, we saved money by running models that are free to use, but we're also asking questions: how do we manage these models? How do we oversee how they are used? And I think that's what open source communities are really used to doing. So yeah, I'll stop here.
Okay, I have plenty more questions, but you in the audience may have questions too. So does anyone, I'll give a pause for a little opening. Yeah, go ahead.
I feel like
Oh wait, someone's gonna bring you a microphone.
I feel like there might have been a little bit too much dismissiveness about risk. I mean, before
Chernobyl, there had never been evidence of a nuclear power plant melting down. That doesn't mean the Soviet Union should have shut down all nuclear power plants, but it does mean it should have thought about the potential of something to happen that had never happened. And at least the framework, as I understood you laid it out, didn't seem to allow for that possibility. We've never gone extinct, therefore there's no evidence. I thought it was implied that we shouldn't consider that.
Thanks. Yeah, I think that's an important question and like an important concern. So I guess there are two ways to think about it, right? Like one of the ways that has been pushed a lot by the AI safety community in particular is we need to forecast the probability that something like extremely advanced AI will kill us all. I think that approach to thinking about like extinction risk is the wrong one. So in one case, you can in some cases, you can have some evidence, for instance, for biorisks and security risks of how these models are actually affecting real world outcomes. I think in the absence of such evidence and in the absence of like the ability even to make probabilistic forecasts, what you need to do is rely on theory. So these are like the two sort of ways of knowledge generation writ large, relying on theory to sort of reach this particular conclusion or relying on evidence. And somewhat like fantastically almost, these represent the two ways of learning from data. So earlier we relied on statistical methods that had theoretical foundations, and now we relied on data-driven methods that use machine learning. So anyway, so coming back to your question, so I think either the safety community or people who are pushing this idea of X risk need to come up with theoretical foundations for how these risks could actually come about in the real world. And on the basis of that, make a claim that, there is this existential risk. For instance, for the case of Chernobyl, the theory would be that nuclear power is very damaging if out of control. The specific way in which it is damaging is it releases large amounts of energy and contaminates a particular area. And the way we can prevent that is by exercising tighter controls. The issue with all of these framings in the existential risk community is that there is no such analogous theory that stands up to even the slightest bit of scrutiny. The greatest extent to which such theories have been proposed are things like AI will become more powerful. It'll somehow acquire the capability to create a pathogen, and that pathogen will be engineered by someone. By the way, engineering a pathogen is like a task that takes leading experts tens of years to do, but somehow magically they'll be able to get this knowledge just from the AI, and that's how we'll lead to risk. So if you look a little bit deeper into the arguments, all of these arguments are being made by non-experts. It's clear that they have not thought through these arguments at any level of depth. And once you actually start talking to the experts, which we've had to do, by the way, because these arguments have gained so much weight in the conversation around AI, you find out that the scenarios and the theories that people have come up with are actually quite weak. So it's not just that a broad dismissal of concerns around existential risk, but also a dismissal of the means by which we arrive to these concerns in the first place. And I think I'm challenging both of these. So we don't have like probability, we can't rely on probability as a framework to forecast risk. And the theories that are given in the lack of like this reliance on probability, the theories that are sort of espoused about how these risks would come about are actually very weak if we actually look at the real world evidence. But I think that's a great question. I think even just thinking about teasing out these two ways of knowing of how we come up with knowledge and how we act on it, I think it's really, really important to go back to. And that's why I think empirical grounding of evidence is, I think, one of the most important sort of questions in today's discussion on AI risks.
And if I could follow up on that. So first, just put a pin at this point, but for us in the open source and the broader like open commons community, what is important to us is whether the marginal increase of risk from releasing a model open source is meaningful to the concerns. So put a pin at that point, because we find that there are risks related to this technology. They tend to be similar or the same for regardless of what license you put on the model, basically. But more specifically about risk, I think what will be a productive path here is to understand that risk arises from how humans use technology. There's a possibility of AI leading to a catastrophe, but that could happen if someone integrates that system into critical infrastructure and it's integrated poorly, incorrectly. There is a flaw in it. I think it's more productive to start thinking it in that way, to remember that we are the people building the technology. We are the people deploying it. It is in the power of the developers and the regulators and policymakers and many other people to control how it's used. And all the risks we see rely on implementation rather than some sort of inherent or latent capability in the model.
So going back to, I mean, what Alek said, that whether we want it or not, risks are a part of the conversation. How do you all think about safety by design along the development chain versus safety that is supposedly guaranteed by deployment level interventions? With the big, like, supposedly here.
Whoever wants to go, can go.
Not big on safety issues. Skip. It's not my cup of tea.
Well,
It have to be safety because it's a loaded word, but
Uh-huh.
managing of risks from deployments of the technology.
Okay, oh, I see that. Mhm.
I can try to take a stab at it. So I think one of the concerns around, like, again, the safety of these large models has been around the fact that who can use these models is the primary sort of reason for risks. And this is also why we come back to open foundation models, and people, if anyone is allowed to use this model writ large, I think that's where the concern is, that, you know, people can misuse it for all sorts of things. On the other hand, like, the first part of your question was about safety by design in terms of how these models are designed and developed. And I think personally for me, that seems like a much more sort of practical and easier to implement type of like safety mechanism, simply because when we have like models that are being openly released, models at the capability levels of like Llama 2 and so on, it is guaranteed that some people might not sort of adhere to the licenses, and some people might not sort of try to follow each line. It's in some cases really hard even to know what the license is asking you to do. So the question then becomes, how are we going to live in this world where anyone can use these types of models for different things? And I think that's where it becomes important to focus more on the downstream interventions of how these models will be used in the real world. So as an example, one of the main concerns around AI models is disinformation. It is true that models at the level of Llama 2, which can run on my laptop like right now, can easily be used to scale up disinformation operations because they reduce the cost of creating disinformation. But the key issue here is twofold. One, the cost of creating disinformation has never been a barrier in the cost of making someone believe your disinformation. My favorite example here is that QAnon, this famous conspiracy theory group, is run by two people. So it is never a bottleneck on the amount of disinformation you can create in order to sort of actually cause harm in the real world. But two, more importantly, the place where this disinformation actually goes out in the real world is not at the level of the AI system. It's at the level of the social media platform. So there, the existing methods that we have, and perhaps the new methods that we need, should be tailored to like this risk of AI. And in particular, like at least from my perspective, being able to scale up already existing mechanisms such as community notes on Twitter or third-party fact-checking, I think becomes even more important. And almost paradoxically, we're at this moment where, you know, the bugbear of AI is sort of haunting all of Western civilization. But at the same time, our investment in protecting against disinformation is going down. Twitter has stopped its misinformation detection almost entirely. Facebook, Instagram have said they've had enough. They're not investing too much more. And I think even YouTube, after the 2020 elections, has loosened its misinformation policies as opposed to the other way around. So the key question we need to be asking is, how are we protecting these downstream surfaces rather than focusing on the AI question? Because I think the AI question here is just like a tangent, as opposed to the real question of what we are doing to protect the surfaces where the harm actually happens.
Yeah, but I agree with you, but I think there's a sort of kind of practical policy challenge there that it complicates the debate, right? And in a way, we all know that these are extremely complex issues. It's already a lot to wrap your head around the AI governance debate. So I kind of get it that then jumping over to platform governance or content moderation is hard, but I agree. I think it's required, and I think that's where the solutions are. I would give a very practical example. I've been following the deepfakes debate. I think there were already, I don't know how many multiple elections were meant to be basically steered by deepfakes. I think for sure your last presidential election, probably the coming one, is already announced. There will also be, you know, the vote will be determined by deepfakes. It simply doesn't happen. People were expecting the war in Ukraine to have extreme levels of AI-driven misinformation. I think that you can count it on the number of fingers on one hand, how many actual cases there were, and they were not successful. And there are very successful disinformation operations happening without these tools, which is also, I think, a good reminder. Of course, we're having an event where the focus is on generative AI, but sort of there is a world beyond generative AI. There are risks that are not AI related. I think we need these more horizontal perspectives. But yes, and just to reiterate, I think that's the strongest response, or one of the stronger one to criticism about open source risks, that you need to look at the attack surfaces. I'm really hoping Europe is well suited to do that with a lot of thinking around platform regulation. I think it can really connect the dots here.
You actually kind of brought it back to what I was going to ask, is like, so all of that you were just talking about, how does a closed or open LLM impact what you just said? Because a lot of what you guys just said had nothing to do with a closed or open LLM. So
on disinformation specifically, I do think that the platform approach and understanding the attack surface is the more productive way of a more productive way of finding out what the problem is and finding interventions that are important. But I think the open and closed debate comes to the forefront when it comes to data sets and open data. So as I mentioned, for research purposes, we would very much like to have more open data sets. And the trend we see in LLMs currently is the opposite. We are having a competition who can say less about the data, as a matter of fact, within industry. Like anyone who pre-trains a model currently, we're trying to find the shortest sentence of how to decline, how to. And this is bad for many reasons. So the reason this is happening is primarily because the data is the secret sauce. The quality of the data generally determines the performance of the model. At the same time, there are ongoing lawsuits about it, and the people who actually deal with the data can talk less and less about the data as a result of the ongoing data lawsuits. So this has a chilling effect on the debate. And furthermore, if we had more open data sets, we would be able to ask more pointed questions about governance structures that are possible. When you're designing a data set, there are a lot of decisions that you have to make that have policy implications. Like, at what level are we happy with a identified PII removal? When are we satisfied with it? Or at what point are we saying that our anti-bias measures are satisfactory? As you can see, these are very, very loaded questions. At sort of open, potentially publicly funded dataset effort could be an opportunity to have a conversation about this in the public, have more people weighing in on decisions. So I think that's how we can bring it back to the open versus closed debate.
1 second, let me actually ask a follow-up and then we'll come back to you. So there was something that Aviya said actually in the opening about sort of what open source means traditionally in software. And this reminded me that, sort of from a computer scientist perspective, I often think of machine learning systems almost as compilers. They are sort of compilers that take data in and produce a program, and that program is represented in weights. And so from that perspective, sort of this notion of releasing weights as being equivalent to being open is kind of nonsensical, because it's essentially equivalent to just releasing the program. But going on that analogy, there's no one from industry on this panel, so I feel like I need to try to do a little bit of what might industry say, right? So I think the usual arguments that you hear are, okay, trade secrets, which you sort of just mentioned, right? The secret sauce is the data. Increased capacity to be sued, because as I make things more open, people can attack them in various ways, and sort of increased risk around hacking and so on, because if people know exactly how the system works, the argument goes easier to break. So those are sort of the 3 common arguments I've heard in favor of closed. I don't think I want to ask everyone to respond to all three, but I'm curious, each of you, how do you think about these sort of counterpoints? And I think we've gone around, so let's start with Alek again, if you want.
Yes, I first of all, I appreciate this exercise to take sort of at face value these considerations, though I have problems accepting some of them. And I think it would be great to be able maybe to have under Chatham rules a conversation. Like the thing I would like to do is sit down with the meta legal team and discuss the Llama 2 license. That would be a dream come true if Santa is listening, for next year.
You have
but
strange dreams.
and maybe the but the case you mentioned about the increased capacity to be sued is an opportunity to talk a bit about copyright, as I think we will need to solve this issue. And I think, again, without going a lot in that direction, it opens the huge, strong in the US debate about fair use, obviously, and I don't think we want to open a lot, but I think it needs to be mentioned. I think that's the huge challenge that we face. Again, the European perspective is a bit different. We have laws on text and data mining, which basically allow for a perspective where, for instance, it's okay to opt out. I know it doesn't, because again, the problem is not with future data sets, but with the existing ones. And I can be very smart about solutions going forward, but will not change the situation. The consideration of costs of these commercial challenges that you mentioned, not just now, but probably for the next 2 years or so, taking into the time account at least current times of development. But nevertheless, I think we should be looking for solutions which maybe would allow business to feel a bit safer to consider sharing data, though I know that sounds very utopian, probably. I will admit that.
I'd like to actually tackle the trade secret argument. Okay, so we know how to train large language models in general. Like OpenAI or the Gemini team, they don't have a secret trove of data no one has ever seen. It's like, we know that there's going to be a scrape of the web in the training data set. It's either going to be a filter of the common crawl, or it's going to be from the Internet Archive, or they're running their own scrape. How is that? That is not a very, that's not a big secret. We just need like kind of confirmation about how things are done. Or imagine that you have a blog, you have a Substack. Is it a secret for a company to answer if they used your work in the creation of the tool? Like, I don't think we should just be accepting trade secret argument on face value.
I can quickly take on the third one. So again, I think the point about hacking is, again, like something that goes back, I don't know, 30 or 40 years. So the concern with a lot of open source software back then, also paradoxically raised by Microsoft back then at the time, was that if you have a software system that is open source, then it's easier to hack it. And again, on the face of it, this seems very plausible. You can look at the code, therefore you can identify vulnerabilities, therefore you can sort of attack these systems. This idea is something that's called security through obscurity. That is, you obscure your systems enough so that you are able to secure them against attackers. Now, it turns out that there are far more people in the world who would happily sort of spot security vulnerabilities in your code and report them to you for a bug bounty, and this process has become institutionalized now, than there are attackers who are looking to find vulnerabilities in every specific code. So because of this, security through obscurity is like an idea that's completely rejected in the security community today. And in fact, in several systematic studies, it's been found that open source software is no less secure than closed source systems. So once again, I think the response to industry concerns around like being able to hack these systems is just that the empirical evidence we have so far suggests the exact opposite, that systems that are open source might in fact be more secure than systems that are closed source. And that there's this famous sort of quote attributed to Linus Torvalds, the creator of Linux, that shallow water makes bugs easier to catch. And that's basically true. Like if you have code that's easier, or another one is called many eyes make shallow bugs. So once again, both of these sort of go back to the concept of people being able to investigate these algorithms as being a necessary condition for the security of these tools in the first place. So once again, I think going back to the idea of empirical findings around what these risks actually mean and our theories around how these risks might come about and testing them against real world data, I think becomes really important.
Can I make like answer a question about the fourth risk that you didn't mention? No, I want to get us just a bit out of the risk debate. I feel I sort of predicted that well, it's self-fulfilling prophecy. But I think we should also be asking about the value of these open data sets. Aviya, you mentioned it a bit. Basically, there seems to be this industry spin that these are some magical approaches, as you said. But in the end, can we make data sets basically a commodity or even better a commons, right? It's not rocket science, and we have great examples also. Wikipedia, again, it seems to be a resource that by virtue of being relatively high quality, available on the internet, under a free license, by now also with very nice technical APIs, is simply used again and again and again. So this is doable, right? And you don't require a company with a valuation of billions of dollars. You require a nonprofit with a budget of, I think, 200 million, right, per year overall, not for their AI team, to be clear. So this puts things into a perspective. And I think, again, we are discussing this also in the context of public policy. There are conversations about public compute. There should be conversations basically about public training data sets.
And a question, who did I nix the question from? Over here.
So I was wondering if we could learn something from the risk management processes of, say, the pharmaceutical industry. So we have some regulation of the production processes at a lab in terms of privacy protection of clinical participants and things like that. But there isn't really too much oversight of the actual production process. But there is quite a bit of oversight of the products of that process in terms of efficacy and safety. And there are outcome events, authorizing the commercial distribution of a particular product. Could the same, what I worry about is that risk assessment has become process rather than outcome focused. Could there be a similar process for the products of AI where there isn't too much oversight of the production, that is, of the internals of the AI research community, but there is quite a bit of oversight of the products of that research and a set of community, government regulated criteria for safety and efficacy, for example.
I can take a stab at it. So I think what you're saying is absolutely true, only for narrower AI systems. So what I mean by that is like AI systems like 10 years ago or maybe 15 years ago were trained to do a specific task for a specific purpose. Let's say we have a recommender system on Amazon. All it's required to do is to recommend what the next product on your shopping cart would be, or like what product would you click buy on. When we have recommender systems on Facebook, it predicts what like a particular image would be. I think the kinds of systems we are talking about when we talk about like foundation models writ large are somewhat different because the purposes they would be used for are dependent on the users who use them. So these have been called like the general purpose technologies, but I think in general, we don't have a specific purpose in mind when it comes to what AI systems should be used for. Like for GPT-4, you can imagine like a lawyer using them for legal research or a medical professional using it for something else and so on. And so what that means is evaluating them becomes really, really hard. I think Sebastian mentioned this in his previous talk as well, because we need to have like an understanding of how users actually use these tools. Because what these tools are being used for is not just a function of the model itself, but rather it's a joint property of the model as well as the users who are using these tools. Now, that is where I think one of the reasons why data is important becomes most clear is because all of the interaction logs of how these models are being used in the real world are trade secrets. For OpenAI, I think it's a big competitive advantage to know what foundation models can be used for. and it is a way to reduce their liability. For instance, if it's found that lawyers are using these models for unlawful legal practice, then there might be some liability on OpenAI. So it's best if they don't disclose these things. And I think because of this perverse business incentive across the industry, I think this is one place where we could think about mandated disclosures as like one way to sort of get to first understand what these systems are being used for in the real world. And I think once we have that information, once we know broadly how these systems are used and to what ends, I think only then is something like the evaluation scheme that you're talking about possible, because then we know what types of evaluation tests we need for safety and reliability. But without this data, I think it's really, really hard. And so I think this is also where like one of my other sort of favorite interventions comes in is I think there's a huge opportunity for research teams to develop ways to sort of collect these interaction logs. I think a few teams have started doing this. And how do we make them available in like a privacy preserving way? And once we start that conversation, I think it becomes a lot easier to then develop the kinds of approaches that are used in medicine. So in other words, I think we are 2 steps away from getting to that space where we can even think about what these evaluations should be. Because right now, we don't know what these tools are being used for in the real world at all.
By the way, can I just add, I think that's a huge advantage of these commercial closed systems that, and the story is just the same as with platforms, that they also are the choke points where the data on user behavior is easily collected. In a decentralized distributed system based on freely flowing open source solutions, this is very hard. And also by design, it's sort of not meant to actually happen. But that leads to this classical, I think, power imbalance that's not easily solved. If I can add to this, by the way, in terms of understanding, I think we need to understand these decentralized ecosystems better. And that's a slightly different point. But so again, interesting, in the previous conversation, Sebastian had this slide and said, 500,000, and he was saying, and I'm very curious, what do people do with these 500,000 downloads? Admittedly, as far as I understand, for now, it's mainly research purposes, but I think we'll get soon to a stage where they will be deployed. We need to understand this a lot. For now, I think the crucial work is to understand the ecosystem of fine-tuning. It's extremely interesting. It was also mentioned, this balance between large systems, small systems. So one system used to provide data to train another synthetic data. We kind of know these stories, but they should be told also in economic terms. I think translated into basically sort of industrial policy, maybe even, because I think for now there's a lot of talk as fine-tuning as something important, but we don't fully understand the process. I'm really looking forward. I hope someone does a study of that.
If I can shout out, there's this thing called the Data Provenance Initiative. It's a large research product, basically auditing, fine-tuning data sets. And it's now actually being expanded into pre-training data sets. But yeah, Google Data Provenance Initiative came out this year. Very good to get more information on fine-tuning data sets. Yeah.
I'd like to follow up on something that Alek brought up, not in the most recent comment, but 2 comments ago, which is sort of around incentives and incentives in industry and incentives around closed versus open source. So from talking to Susan, who is here somewhere, I don't know where she is, right? Like, oh, there you are. Thank you. Right in front of me. So, there's sort of like carrot and stick approaches to regulation, right? So you could, for instance, say, okay, if you're not going to make your thing open source, like, we're going to put all these restrictions on how it can be used, right? That's sort of like a stick approach, right? You could also imagine governments like actively incentivizing the creation of open data repositories and things like that. So in this sort of broad space of, let's take for granted that we believe now that open source is good. So taking that for granted, what could or should governments do to either disincentivize closed or to incentivize open? And I have no idea where we were last time, so whoever wants to go first.
To some extent, I think this is we're starting to see it in there, for example, and how they're thinking about how to make their resources most useful. So I think there are definitely connections with just like, first of all, expand the idea that publicly funded research should be publicly available. Expand that principle to computer science. That's sort of, easy. Won't call it easy, but step number 1, that's concrete enough to point to, I think.
I think in the US context, one of the places where I'm most sort of optimistic is what Jen mentioned in the first panel, which is procurement. So the US government is actually responsible for buying a lot of software products. And traditionally, the Office of Management for Budget, I think the OMB, has had a very pro-open source stance. So I think in a lot of the procurement initiatives they lead, they ask companies to make their software open source before they even consider purchasing them. So even to enter the tender process, you have to release your entire software open source. And I think that's one type of lever that the government has as like a carrot, because you don't necessarily, so companies don't have to follow these. So concerns around like First Amendment protections and so on don't come into the picture. And yet companies do want to compete for these tenders, both for like visibility purposes to say that they're being used by the US government, but also just for like monetary purposes, because the US government is a big purchaser of all of these products. And so that is one sort of approach which seems like doable within the current policy sphere, does not require us to like come up with a new regulatory regime, and still does not sort of upset companies too much. So it seems to hit the holy grail. But yeah, I mean, apart from that, I think Aviya mentioned the NAIR. I think that seems like another sort of possibility, though it's still like not an act yet. So that's important to remember.
I guess for that to be useful, you'd have to be clear about what the definition of open source means for AI systems.
Exactly.
Alek?
I can highlight, I think there are also interested things, simply funding policies, which again have existed admittedly at limited scale for open source. You had the Open Technology Fund here in the US. Germany probably has the most robust initiative called the Sovereign Tech Fund. I think its current funding is at the level, I might be wrong, I think it's 100 million per year. So probably not a lot in this context. But you can scale, and I think also if you listen closely, there is talk about these hugely funded projects, but there's clearly also room to do good work with much smaller budgets. So that's it again, and I like your also. These are in theory, there are simple rules, not easy to implement, but I would like to see these funds develop both here in the US and over the ocean. And I think in the current sort of debate around digital policy, focusing on them on AI solutions would be the right call.
Great. Audience questions? Yeah.
Thank you for this panel. I lead the Modernizing Congress portfolio at Georgetown's Policy School, McCourt. And I've been supporting the Modernization Committee in Congress for the last 5 years. The next, it changed 202 recommendations over the last 5 years, and it took the pandemic to get Congress on Zoom. Its data is everywhere between testimony to shoeboxes in the basement of Rayburn full of yellow sticky notes. I mean, it's crazy. And the next challenge is going to be looking at Congress as a publishing entity, must be in the top 10 in the world. It's just massive. The whole memory of democracy is in the first branch of government, but it's not accessible. If you were looking at Congress as a data training model or a large language model to protect democracy, which is like, I think, the next front in the sort of authoritarian versus democracies in the world, where would it fall on this continuum? Like, some of it's going to have to be closed, but so much of the data in there is already public and is supposed to be public, just testimony, and it's already curated, it's already footnoted. So it solves some of the provenance or supply chain authenticity problem. Where would you put it? Like, because that's going to come up in the next couple of years as a data governance, institutional governance strategy for Congress. I know that's huge, but it's a very real problem right now.
Can I start? So I think that's a really, I don't have, I will immediately say an answer, but it sparks some thoughts. I think we are facing some key questions basically about knowledge management at institutions, right? And picking any such crucial institution like Congress is probably a great place to start. For me, the key question is, there's one question whether you want the data to be available, right? Funny fact, some of the open source, and probably also not the open source, but the publicly, for instance, the Pile includes data on the European Parliament.
Yeah.
And I like to think that therefore anyone using the popular probably ChatGPT speaks a bit like a European parliamentarian, which I think is extremely funny. But that's one interesting question. I think it's not a solved issue, but the conversations we had about open government data, I think kind of give you a framework to work with. The more interesting question for me was whether Congress should deploy its own models, and then whether it makes a difference that they're built and managed by Congress or not. And this is where I'll look at first you, Aviya, because I lack technical expertise. I can imagine it. I would like someone to tell me maybe it's a silly idea that you need to own your own model, but at least I would like someone to explore it. Because it's gonna be, it's a new mode of working with knowledge. We know that, right? And I think also when you mentioned post-it notes, that's tough. The European Parliament has some kind of, for instance, format of documents, which is based on, I think, Word files, and some very traditional way of formatting text that I don't understand why someone doesn't make it machine readable. It feels really easy to do, but they're simply not doing it, as if there's like a tradition to make it complicated and force everyone to send files instead of having, I think they should have something like GitHub, basically, like version control.
Yeah.
You win.
So just to confirm, yeah, so our training dataset actually contains like data from the European Parliament as well as other government data, for example, USPTO. We are very interested in government data actually because it's just, there's a lot of it. And as you've heard multiple times now, we need a lot of data. We just need a lot of language, basically. The challenge that we face is that, it's under different agencies and they're not always cooperating and they have different ideas about how to release it. So, but from our perspective, all we need is to just, for things to be digitized and sort of in one bucket, data.gov or data for machine learning.gov. And even if it's just scans, we have OCR and like we can process that. But it seems to me, and we've had this conversation with like USPTO and there's like somewhere there needs to be an employee somewhere whose job it is to bridge the divide between the documents as produced by the government and as made available. It seems like it just sort of, when we ask, it just sort of like no one's job. But
under the Evidence Act, they are supposed to make all US government documents machine readable format. And that law was passed, I think, 2020, maybe even right?
yeah, so
The branch is like 10 years ahead of the House, the Congress, Congress itself as a publishing entity. It doesn't even compete right now.
Also, like a machine readable format doesn't mean I can like download it. So, but there's a huge amount of data that's like theoretically publicly released, but is undocumented, or it's like the government doesn't tell you where to find it. That like makes it functionally unusable.
yeah, so where to find it, where it is, that kind of thing. But it's not somewhere a button needs to be pushed, but the sort of like, in order to bridge this gap, I don't think a lot of investment is needed. It just needs to be targeted by someone who have a good understanding of where the disconnect is, because we have an understanding that data is available and there's even some will to make it available. And I think a small team of people could make a very large impact here by opening this data more broadly.
So I'll just add one very quick thing is like the IRS, I think as of this year or perhaps the last year, has a chatbot, which is trained on this IRS data and it's intended to answer tax questions. And so this is like just an example of how even if you do have the data and if you train a chatbot, it can go quite wrong because the IRS provides no protection to people who use the chatbot. So you could go to the IRS website, use that chatbot to answer your tax question. And if the question is answered incorrectly, which it is quite probable that it would happen because of the limitations of current language models, then you're entirely responsible. So I think this is just to say that, I do think we should think about modernization, but also at the same time, limitations of current technology make it so that like these models hallucinate a lot, and having this sort of liability fall nowhere, or actually perhaps even worse on the end user, makes it very hard to deploy them in any really consequential scenarios in the first place. And just because the data is accurate, I think, is not at all a guarantee that the outputs of models trained on that data would also be accurate.
Right, yeah, just to be clear, this is like a technological limitation of like the architecture, what LLMs are. And for our part, like the large reason we focus in research is that we don't feel the technology is quite mature. But this is why I suggest starting like with the data and opening data up that opens so many avenues of research, and we can continue working on improving like reliability. Maybe at some point there will be a reliable enough iris chatbot, but I completely concur that right now it's a terrible idea.
Which makes me think maybe it's good to mention just a bit the issue of capacity, especially in public administration, right? This is a clear case, right? I think it's a terrible idea to deploy chatbots. I've seen some attempts. I understand the need to rush. I was, for instance, at a meeting where the project is sort of nice. It kind of matches tech companies with nonprofits to build solutions, and they now decided they will build AI solutions because it's 2023, right? And you do that. And they're thinking about, there's a nonprofit working at schools, which has amazing after school program where teachers are meant to mentor students, and they realize the teacher can mentor only 5 groups, but there's a need to mentor like 20 groups. So they decided they'll build a chatbot, and it all sounds great, but they ask them like, so what's their framework? Not risks, right? They're not scared that it'll start spewing out, I don't know what, something extremely nasty, but just like walking through the steps of understanding what it will mean in your nonprofit, in the schools. They have no framework for that and extremely little capacity. And they're matched with communities with very high capacity, but mainly technical ones. So you can see there's a gap there. And I know it's like kind of weird to have tech policy conversations and basically start talking that we all need to get educated, but I think that's kind of the truth.
I think we had a hand up here.
Yeah.
This might be the last question. We'll see how it goes.
I'm, oh, okay. I'll be sort of the ant at the open source picnic. Looking at it from a proprietary commercial operations perspective, open source sort of started particularly via APIs, et cetera, where there was an incentive for the business, for example, you know, Google or Microsoft or whomever, to encourage app developers to develop applications that would really just enhance utilization of its core product. If you don't have that kind of business model, say you're a pharmaceutical company, and you're developing internal code bases which utilize in the overall architecture LLM capabilities now, generative AI, just to facilitate researchers' work. You're not going to want to make that open source API. Excuse me, open source. Maybe some aspects of it. Are you? I mean, what would be your incentive to go open source? And also there's a knock on open source now among, again, commercial endeavors, that it's a potential source of cybersecurity risks and vulnerabilities. You have to go through a lot of verification now that the open source is indeed safe to incorporate as a component as your overall supply chain or architecture. And so I'm just wondering if, you know, perhaps the title is great. It's a continuum, but there's a lot of that continuum that open source, I don't see where it makes sense from a business's perspective. Thank you.
Can I just make one comment to counter a bit your example? If taking into account that most businesses, they're not building their own models, right? They are downstream users of models. There's a lot to investigate in terms of security risks of using, and there are already business cases that how secure do you feel about taking a proprietary model about you, which you know nothing, and deploying it in your pharmaceutical company? If I was a lawyer, I'd ask serious questions. So bottom line is, I think for some reason we're asking security questions about open source that we avoid asking about closed source solutions. It would be really good to level this field.
So I have two quick points to make. The first is, I don't think I'm saying that all models should be open source. I think the claim that I'm making is some models should be open source, and we shouldn't take people's ability to make these models open source away. So for instance, like a lot of the policies that have been floating around recently, like the Blumenthal and Hawley framework for regulating AI, I think they impose liability on downstream users of these models, and I think they also advocate for licenses for building these models. Both of these would mean essentially the destruction of the open source ecosystem, because there's no way an open source actor like Eleuther can monitor how downstream actions takes place using their models and how like people are using their models to harm others. So I think that's the wrong regulatory framework. And so all I'm saying is like this type of policy approach, which effectively bans open source, I think is not the way to go. On your point about the example, I think I concur with Alek. For a downstream user of these models, I think it is always, especially for a pharmaceutical company, it is much easier for them to use open source models compared to closed ones, simply because for closed models, your data is going to a third-party server. So when you're using GPT-4, your data is going to like OpenAI servers. When you're using models from Microsoft, it's going to Azure. But when you're using open source models, you can actually run them within your own services. So of course, I agree that there's a question of security of how fit for use these models are. And I agree that like a large number of these models are not fit for use in healthcare settings. And that's also true for closed models. But from the perspective of like security within a firm, I think it's unquestionable that open foundation models that can be run on like your, let's say your personal computer are much more safe in terms of not leaking private information about your users and not disclosing them to like a third party.
Just I'll do a quick response. No, I'm sorry. We can't, please go up afterwards, but.
Yeah, do you have anything you wanted to add?
I think we're good. I mean, so what Sayash was highlighting, I think illustrates how like open source is like as a concept and as a legal framework, it functions very well when it comes to infrastructure, which is why you were mentioning an open foundation model. What we see in these sort of like critical applications, like in healthcare, is that some of the developers will take something that's open source and then build on top of that, and they might not open source that thing that they built for their application. But under an open source license, there's no obligation to then open source whatever you built on top of it.
All right, I think we're basically out of time. So thank you, audience, for participating. Thank you, Alek, Aviya, and Sayash for paneling.
Okay, so we're actually going to have a break now, cookie break. For 15 minutes, so please come back. And Anne, you are very welcome to continue your discussions.
Exactly.
Yeah. Oh, probably nothing interesting, I assume. I know more about the European.
Or like a very good example, I should say. Nice to meet you.
Sorry you're from That's okay. I've heard a lot of good things about
How you doing? Okay.
and I focus on species, US
Right.
and part of the Open Unix Foundation.
Okay.
And we work on the policy part of human machine relations.